All right, welcome. Think about this for a second. The last thing you touched, your phone, maybe a light switch, it's all powered by this invisible force that, basically runs our entire world. But how does that force, electricity, actually get from the wall socket into your gadget safely and, well, effectively? Let's unplug that mystery.
Okay, so check this out. This is the heating element from a regular old electric kettle. It looks super simple, right? But it's actually a masterclass in practical electricity. I mean, how does this one little coil get hot enough to boil water in just a couple of minutes? The answer? It all comes down to one crucial ingredient. And that secret ingredient is power. Yep, electrical power. It's basically the engine driving every single appliance you own. It's the thing that tells us how quickly your kettle or your TV or your game console is gobbling up electrical energy. So how do we actually measure this stuff? Well, there's a simple but really powerful formula for it. Power equals voltage times current, or as you'll see it, P equals V times I. So think of it like this. Voltage is kind of like the electrical push or pressure coming from your wall socket. And the current? That's the flow of electricity that the appliance is actually pulling in. You just multiply those two together, and bam, you get power. And we measure that in a unit called watts. The more watts, the more energy it's using every single second.
And you've definitely seen these ratings all over the place. Like, take a look at this laptop charger. See that? It's rated at 65 watts. That number isn't just pulled out of thin air. It's telling you its maximum rate of energy use. It's like a quick label that tells you how hungry for electricity an appliance is. A beast of a gaming PC might use hundreds of watts, while a tiny little LED bulb might use less than 10.
Okay, so this is a really, really crucial point to get straight. The difference between power and energy. They sound similar, but they're not. Here's a great way to think about it. Power is like your speed in a car, how fast you're going right now. Energy, on the other hand, is the total distance you've traveled. See the difference? Power is the rate of use, and energy is the total amount you've used over a certain time.
Right. So if power is the rate we use energy, how does it actually connect to something we all have to deal with? The electricity bill. Getting this difference isn't just about passing your physics exam. Trust me, it's the key to understanding exactly what you're paying for every single month.
You know, your electricity bill doesn't actually measure energy in joules, the standard unit. Why not? Well, the numbers would be absolutely massive, like ridiculously big. So instead, the utility companies use a much more practical unit, the kilowatt hour. And what is that? It's super simple. 1 kilowatt hour is just the amount of energy that 1,000 watt device uses when it runs for 1 full hour. And the little gadget that's keeping track of all this, it's your electricity meter, probably sitting on the side of your house. That thing is constantly ticking away, counting up every single kilowatt hour your whole household is using. You can think of it as the official scorekeeper for your home's energy game. So you want to calculate the cost yourself? You totally can. It's a really simple 3-step process. First up, you take the appliance's power in watts and convert it to kilowatts. Just divide by 1,000. Easy. Step 2, multiply that by how many hours you used it for. That gives you the total kilowatt hours. And finally, step 3, you multiply that number by the cost per kilowatt hour, which you can find right on your electricity bill. And just like that, you can figure out exactly how much it costs to run pretty much any device. Okay, but electricity isn't all about power and cost, right? It's also got let's say, a dangerous side. When all those carefully designed circuits we rely on go wrong, things can get hazardous, and they can get hazardous fast. So 2 of the most common hazards pop up when electricity decides to go somewhere it isn't supposed to. First, you've got damaged insulation. This can expose the live wire inside, which is a huge shock risk. And then there's overloading sockets, plugging way too many things into one extension cord. That forces too much current through the wires, causing them to get super hot. And that is a major, major fire hazard. And then, of course, there's water. There is a very good reason you don't find electrical sockets right next to your sink or inside your shower. Now, pure water is actually a pretty bad conductor. But the water from our taps, it's full of impurities. And those impurities let it conduct electricity really well, Water basically creates a shortcut for the current to flow where it shouldn't. That's why the whole hairdryer near a bathtub scenario is such a classic and deadly combination. But hey, it's not all doom and gloom. Thankfully, your home isn't just left defenseless against all this. It's actually filled with a bunch of clever safety devices. Think of them as your home's electrical bodyguards. And they are designed to protect you from these exact kinds of hazards. Your first line of defense is going to be either fuses or circuit breakers. They both do the exact same job. They keep an eye on the current. If the current gets too high, wham, they shut off the power. The main difference? A fuse is kind of like a one-shot device. There's a thin wire inside that literally melts, and then you have to replace the whole fuse. A circuit breaker, on the other hand, is just an automatic switch that trips, and you can just flip it back on. So where do you find these bodyguards? Well, they're usually all lined up in your home's distribution board. You might know it as the fuse box. This thing is the command center for your home's electricity, with a different circuit breaker protecting each part of your house, from the kitchen lights all the way to the sockets in your bedroom. But here's the thought. Fuses and circuit breakers are great at protecting against too much current. But what about a totally different kind of problem? What happens if, say, a live wire comes loose inside your washing machine and touches the metal case? Well, the answer is pretty terrifying. Without any protection, that entire metal case would instantly become live. The second you touch it, your body becomes the easiest path for that electricity to get to the ground. And that means a massive, potentially fatal current would flow right through you. Okay, now let's bring in our most important bodyguard for this situation, the earth wire. This is a wire that connects the metal case of the appliance directly to the ground. So now if that same fault happens, the earth wire provides a super safe escape route for the current. This causes a huge surge of electricity that instantly blows the fuse or trips the circuit breaker, cutting off the power long before you could ever touch it and get a shock. It's a really simple idea, but it's an absolute lifesaver. All right, so let's do a quick recap of our electrical safety team. We've got fuses and circuit breakers to stop current overloads. We've got the earth wire to protect us from faulty appliances with metal cases. And what about things made of plastic, like a hairdryer, that don't have an earth wire? Well, they use something called double insulation, basically 2 layers of plastic, so there's just no way you can accidentally touch a live part. So, there you have it. You now have the power. And I don't just mean the power to turn on your devices. I mean the power to actually understand the physics that's happening behind the scenes, how they're powered, what they cost to run, and how they're all designed to keep you safe. So let's just nail down those key takeaways. Remember, power in watts is all about how fast an appliance uses energy. The cost you pay depends on that power and time, which we measure in kilowatt hours. And most importantly, while electrical hazards like overloading and damaged wires are very real risks, that whole system of fuses, circuit breakers, and earthing works together to create a really strong safety net that protects you every single day. So, I'm going to leave you with a challenge. Go look at the appliances in your own house. The kettle, the microwave, maybe the air conditioner, or the TV. Which one do you think uses the most power? The cool thing is, now you have the tools not just to guess, but to actually figure it out. Thanks for watching The Explainer.